Hello, everyone. So a quick show of hands. How many of you have ever asked yourself this question? Right? Yeah, a room full of people, I expected exactly that. It's a question which people new to Go are very likely to ask, I think. But even if you've been doing Go for a while, even as an experienced Go developer, I think you still find yourself coming back to this question all the time. That's certainly where I have been. I have asked this question myself a lot of times. And I've been a full-time software developer for about 7 years. I've only been doing Go for about 2 years, so I still very much consider myself a newbie, not really an expert. And I'm still fairly unsure about some things, until now. And the idea for this talk came to me when I started thinking about a bit more consciously about the best way to structure my code, because I've been kind of doing Go for a bit, and I was like, that doesn't sound quite right. So let's actually dig into this. So there were a lot of questions that I had, and a lot of decisions that I felt like I had to make about my code. Should I put everything in the main package? Should I start with one package and then extract other packages over time? How do I decide if something should be in its own package? Should I just use a framework and be done with it? And what's the programming paradigm for Go? Is there an idiomatic Go way of structuring your apps? Should I go for microservices? Should I stick with a monolith? And how much should I share between packages? Should I make them completely independent? Or should I maybe share some stuff? So I'm sure a lot of you have had these or similar questions. And when I was doing my research online, there is some information online, not an awful lot, because application structure doesn't tend to be one of those hugely discussed topics. And usually the focus is on the design itself, like design patterns, but not so much on the where do my files go on disk kind of question. And then everybody seems to have a slightly different answer to that. A lot of people have their own preferences that they stick to. And Go as a language kind of leaves it up to you. It doesn't really give you any hints. You kind of start with a blank page. And I think it's fun, because we can experiment to our heart's content. And we can tailor the program and the structure to our exact needs. But it means that it might be hard to get started, especially for somebody new to Go. Or for those who don't necessarily have a C background, or for those who don't come from or for those who come from the traditional object-oriented languages like Java, and they expect to see classes in Go. Why is this important? Why should we care about structure? I mean, end of the day, it's just trivial. It's putting files on your disk. Who cares, right? Well, Dave Cheney said in his Golang UK 2016 keynote that if Go is going to be the language that companies invest in for the long term, the maintenance of Go programs, the ease of which they can change, will be a key factor in their decision about using Go for their next project. And I think that's very true. Without a good strategy applied to your project, you'll find your code just getting more and more messy over time and with no structure. And typically, once you make a major architectural decision about your code and you get a few use cases for that developed, it's then really hard to shift gears. So you're kind of stuck with it. So I think it's important to consider it and try and get it right-ish from the start. So what's a good structure? Well, let's try and define that first. Ideally, it should be consistent across the project. There is nothing worse than coming to a code base and seeing one part of the app done in one way and then another part done in a different way. And especially if you're not the original author and you're just coming to a new code base, you have no idea which one is the one that you should follow. And I think a good code structure should be easy to understand, it should be easy to navigate, and easy to reason about. So it should just make sense. It should be easy to change, loosely coupled. It should be easy to test, shouldn't hinder testing in any way. It should be as simple as possible, but no simpler. And I absolutely love this quote. It's attributed to Einstein, and I think it just captures the Go way of thinking perfectly. So keep it simple, but not simplistic. And the design of your code should reflect exactly how your software works. And the structure of your code should follow the design exactly. So if we apply the transitive law to this, the structure of your code should reflect how your software works. You think that's obvious, but how many times you've come into a project which seems to be structured in one way, but it actually works in a completely different way? And this is ultimately the holy grail of good code structure. Your design could use any of the paradigms. It could be procedural, it could be object-oriented, it could be functional, it could be concurrent, it could be node, it could be not. It doesn't matter. Whatever it is, you want your structure to reflect that design that you've decided on. Why is this so important? Well, your code is it's ultimately your only up-to-date documentation of your design, of your business logic, and of the language that you use throughout your project. So a good code structure which isn't diverged from the design is critical to make your code understandable and maintainable. The TLDR of this, I guess, is that good code structure will make your life easier as a programmer, because the code structure should work with you and for you, not against you. And it should make coding a pleasure. I mean, if you have a good code structure, coding is a pleasure because you know where everything goes and you know where everything is. So how do you get to that point? Well, the sad news is that it kind of comes with practice. There sadly isn't a lot of definite instructions that I can give you to follow, but I thought I could show you a few different ways in which you could structure your projects. So I didn't want to use an example with foos and bars because that's not really what real life is like. So I thought, let's use a simple but a more realistic example. So imagine I gave you this spec for a beer reviewing service. And this, by the way, has totally nothing to do with what was on my mind when I was writing the talk. Nothing at all. So I want your app to let users add a beer. I want users to be able to add a review for a beer. And I want users to be able to list all the beers and list all the reviews for a given beer. And for simplicity, we'll skip updating, deleting, and so on and so forth. So it's not a full-blown API. It's just a simple example. And then on top of that, I want your app to provide me the option to store data in memory or in JSON files. And again, in real life, that could be I want your app to support a SQL store and a NoSQL store, for example. But for simplicity, we'll just go with in-memory or JSON files. And then I also want the app to provide me some ability to add sample data, to seed the database and pre-populate it with some beers and some reviews. OK, so now that we have a spec, let's think about how we could go about implementing this. Let's start with the most obvious one, the flat structure. We could have the following files. We have data.go for the sample data. We have handlers.go for our HTTP handlers. We have main, which is obviously main and starts everything up. And then we've got model for defining our beer and reviews models. And then we've got storage, which defines the functionality of the storage that we want to provide. And then we've got a file for each of the storage implementations. So we've got one for JSON, one for memory. Nice and simple. I think that structure is great for this app because it's easy to navigate, it's easy to reason about. And I think it's a great starting point if you just don't know where to start with your app. If you don't know where to start, I'd say go with the flat structure. Flat structure works really well for smaller apps and libraries, like maybe 10 to 20 business operations. It goes well with the idiomatic Go approach because you keep it nice and simple. You don't overcomplicate if you don't need to. And the one great benefit of the flat structure is that it removes any chance of circular dependencies because everything is in the main package. Well, that also leads to some disadvantages of that, because everything is in a global state. So you don't have the option to black box or separate some things out. Everything can be accessed and modified by everything. Secondly, looking at the structure, can you tell what this app actually does? Looking at the file names tells you nothing about the app. You have to open the files, dig through the code, and then piece it all together in your head. And so just to show you what it's like, I do have a Git repository with the demo files, and there is a directory called flat in here where I've implemented all of this. I'm going to share a link to this online, so we don't have to worry about it for now. You can go through it in your own time if you wanted to have a look at how it's done. So let's see if we can maybe break this up into a few smaller packages. Well, there are, of course, a few different ways we could go about that. So let's first try grouping code related to a specific function performed in the app. So this approach is formally called the layered architecture. If you imagine your application having different layers, the UI or the presentation layer, and then the business logic, and then any external dependencies or third-party apps, third-party APIs, databases, infrastructure, all of that. So we could group our code based on which layer they belong in. So if I said to you words like controllers, models, views, DAOs, data access objects, or actions, that all sounds very familiar, right? Like it sounds an awful lot like in classic MVC. And that's a very popular pattern. It's used by a lot of languages and a lot of frameworks out there. So we could have in our main app, in our example app, those three packages: handlers, models, and storage. So the good thing about this structure is that it's easy to decide where everything goes, what goes where, at least up until a certain point. And it also discourages you to use global state, and it kind of encourages you to put relevant things into the same package. The slight problem with that is, for example, if you have a variable that is shared between the layers, well, which layer do you put it in, or do you just duplicate it across layers? And where do you initialize everything? Does main initialize the storage and then passes it into each model? Or do you leave it up to each model to initialize its own storage? So that's kind of the dilemma that you might be facing with this. And in our case, do we have one file called beer.go for everything related to beers? Or do we have one file, one model for a single beer, and then another model file for multiple beers? Also, in this case, if we have one definition of the beer struct, then it means that everything shares that one definition. And that doesn't let you apply different contexts to it. So to give you an example, when I'm adding a beer and I use the beer structure, it has a beer ID. But when I'm adding a beer, my feeling is that I shouldn't need to specify the ID, like the app should handle it for me. But the struct has it. So as a user, I don't know if I need to specify it or not, just based looking at the struct. But then when I list the beers, I want them to come back to me with the IDs. So that's why we need the ID in the struct. So the code doesn't really guide you as a programmer for like which fields you should use. You kind of have to reason about it and work it out yourself. And then the biggest con about this structure is that it actually won't compile. So if I switch back to, oops, jump right up ahead. If I switch back to the demo app, and we go into our layered directory, I've lost the terminal in here. But anyway, if you try to go run main go, it won't actually compile. It will tell you that there are circular dependencies. And the circular dependencies are between the storage package, which uses the models package for the definitions of beer, and then the models package uses the storage package to actually call out to the database. So you've got that nice little loop in there. And then, again, back to the models and the one file for everything. Those files can get large over time, and so they may become not very maintainable at some point. This structure also doesn't really give you much of an idea, much more idea than the flat structure about what this app actually does. So let's try a slightly different approach. Let's try to break up our app into modules. So for example, we could have beers, reviews, and storage. So the idea here is that everything to do with beers goes in one package, everything to do with reviews goes in another package, and then everything to do with storage goes in its own package. So at least now, things are somewhat grouped logically. But that's probably the only advantage we get with this approach. It's still hard, for example, hard to decide if reviews should still go in the beers package, because they are beer reviews, or do they warrant having their own package? Naming is worse, because you've got beers.beer now, so you've got stutter. And then if we jump back to the demo app, whoops, and jump into the modular section, you start running into funny naming clashes. So for example, in storage, to avoid the stutter, the JSON implementation of the storage, ideally you wouldn't want to call it storage.json storage. But if you try to rename it to just JSON, so if we remove the storage from here, then I get an error. It says JSON is redeclared in this package. And it is redeclared as a type of the storage in the same package. So the storage type defines two types, JSON and memory, and we want to call it JSON. But then if we actually want to call the JSON implementation storage.json, we run into this funky name clash. So I kind of had to compromise here and call this one JSON storage. Not ideal. So let's try a different way, grouping by context. Well, what do I mean by context? Well, this way of thinking about your application is known as domain-driven development. So this is an approach to software development popularized by von Vernon in his famous red DDD book. And it may seem fairly complicated and academic to you at first, and it is quite a thick book. But it's actually quite a natural way to think about your design. And DDD is absolutely not about where your files go, but it can guide your code structure really well and help you find the right one really well. So what is DDD and how does it work? Well, first of all, it makes you think about the domain that you're dealing with and all the business logic in your app before you even write a single line of code. So you defined your bounded context, that's a formal term used in DDD, and then the models within each context, and the ubiquitous language, which is another term used in the DDD world. What is a bounded context? Well, it's basically a limit around your particular model. So it's kind of like a boundary around a particular model, and you can have many of them in your app. So to give you an example, if you think of an app that has a user as an entity, then in the sales context, a user might have properties like the lead time or cost of acquisition, but that's one context. But a user for somebody working in customer support will have completely different properties attached to them, like response time or the number of tickets submitted. So we have two contexts here, and we were talking about the same thing, the user, but it just may mean different things to different people. And that's exactly what the different contexts are. So you just define those. And the bounded context help you decide what has to stay consistent within a particular boundary, and what can change independently. So for example, if later on we wanted to add a new property to the user from the sales point of view, like the number of days it took to onboard the customer or something like that, then we can change that without affecting the other context, which is the customer support context for the user. So then you start defining the building blocks of your system. And there are a bunch of them defined in DDD. So you kind of start to think about whether something is a value object or an entity or an aggregate or a repository. And this all sounds really formal, and I'm not really going to go through the formal definitions of each of these. You can look them up online and spend some time trying to understand it in your head. But I will try and explain what they are based on our example app. So we could think of our demo app as follows. We only kind of have one context here, and it's for a beer connoisseur who wants to give reviews for a beer. So it's kind of like it could be a beer tasting context, maybe. So to that person drinking the beer and wanting to review it, the beer has a specific meaning. And that person cares about things like the ABV, like the alcohol context, and the flavor notes. But it doesn't really care about things like the barcode. But however, if we had a different context in our app, for example, for a beer manufacturer, the barcode might very much be an important part of the beer. And then the language we're going to use throughout is beer, reviews, and storage. And You might think that's obvious and it's just a waste of time, but it actually saves you a lot of inconsistencies down the road. Because how many times you'll set off writing something calling the storage, and then somebody's going to use the word database, and somebody's going to use the word repository, or you're going to have different UK and US spelling. I've had that in my projects as well. And then you just don't know which one to use, and it's all inconsistent. So it's quite important to actually define the language that you're going to use in your code base and when talking to other people. And you shouldn't just be talking to your dev team or your fellow developers. You should be talking to all the stakeholders in the business. So this language is a language that everybody, all the stakeholders in that application can use, whether it's support people or your salespeople or your developers or your testers or anybody else. And that actually helps massively because sometimes you might be discussing the application with a developer using this language, and then somebody, I don't know, from the sales department is going to overhear it and go, hey, that's not how it works. Because they can understand the language. You're no longer talking in just dev terms only. So the entities that we're going to have is the beer and review. And the second thing is value objects, which could be things like the brewery or the author of a review. And then what's the difference? Because that can be a bit tricky. So when you think about an entity, you think about an abstract concept that then can have instances. So for example, things like a customer, an order, a blog post, a beer, those are all entities, and they can be instantiated. And a value object is a very similar concept, but it represents a value that on its own isn't really an entity, but it can be a part of it. So for example, a barcode value object is part of the beer entity. So they're a bit more like properties to entities. And then on top of that, we've got aggregates. And aggregates combine the entities together. So if you have two entities that are related to one another, so for example, in our case, we have a review that is related to a beer. So the link here is the beer ID, because the review needs a beer ID to then be linked to a particular one. Then ideally, you could put an aggregate above those two to create you like a meta entity, which will be the beer review, which will be comprised of those two entities. And then services are stateless operations that kind of go beyond a responsibility or a natural responsibility of a particular entity. So it's something that an entity basically shouldn't be doing. It's an operation that an entity shouldn't really be doing on its own. So in our case, we have a beer adder or an adding service, and a listing service, and a review lister, and so on and so forth. And then events, the one definition that I sort of really like about events is that they capture a memory of something interesting that happened in your system that can affect the state of the system, and it can affect the state of your application. There is nothing more to this. They are just what it says on the tin. It's events. So things like errors or acknowledgements and so on and so forth. So in our case, we can have things like the beer was added, the duplicate beer was found, or beer was not found, and so on and so forth. And then, last but not least, the repository is essentially, it basically provides a facade over some backing store. So it is the thing that sits in between your domain logic and your actual storage or database. So in our case, we have two. We have a beer repository and a review repository. And let's not forget that we're thinking here in abstract terms. So these could be one database, or it could be two different databases. We don't care at this point, because that's an implementation detail. We think in abstract terms here, so we have two repositories in this case. And this may not be 100% correct. This is just my take on it. And obviously, if you discuss it with your team, and as you discuss it with your team, you get to refine it a lot more. So by all means, it may not be 100% correct. You could go about it in a slightly different way. And I'm kind of really stretching it here, because our example is really simple. So you're going to see in the actual implementation, I didn't implement the aggregates. I didn't mention factories here. Factories are for constructing more complex objects, because we just don't really have them in our app. So in the real world, you could definitely be dealing with this kind of complexity. Like if you have an order, which is an entity, for a customer, which is another entity, so ideally you'd have an aggregate over those, and then the order has a product, which is another entity, and the product has a price, which is a value object, and so on and so forth. So in the real world, you certainly can come across this kind of complexity. And DDD just helps you to understand all the processes that are going on in your app, and what is what in your app. Is something a value object, or is something performing a function? But as you can see, you can apply DDD to problems of any size. Like, I managed to sort of flesh this out for a simple demo app. So don't be afraid to just leave out some things out of it if you just don't. It's not like you have to have all those things in your application. So as a first take on this, we could have the following. The main change here is that now our package names communicate what they provide as opposed to what they contain. So we have an adding package, a reviewing package, a listing package, and beers and reviews. So this makes it easier to avoid circular dependencies, because now we don't have the one that we had before, because now our adding and listing and reviewing services talk to storage, and storage pulls from beers and reviews. But then the model packages, like beers and reviews, they don't care about storage directly. So we've broken that link. So we no longer have circular dependencies in here. But there's one slight problem with this. For example, looking at this, how do I add the sample data? Like, so far, in all the structures, we've had the adding of sample data bundled into the main function. So we have no control over it. We can't run it separately. It's not independent from the app. And then the question is kind of, where does the sample data adding go? Like, we only have one main function. And also, what if I wanted to add a completely different entry to this app? What if I wanted to make a command line version that would prompt me for the beer properties and the reviews to add, rather than accepting HTTP requests to add stuff? It's kind of tricky to then add this to this structure. But there is something that can help us here, and that is called the hexagonal architecture. So in a nutshell, you start distinguishing between the parts of the system which form a core domain, so the business logic, and all the external dependencies that are just implementation details. So the external things can be anything from external other clients, or external APIs, or databases, or mail clients, or cloud services, anything that your app interacts with. Why is it this way? Well, the goal for the hexagonal architecture, the problem that it's trying to solve, is to give you an ability to change one part of the app without having to change much else. So making a small change to an app, like changing the type of interface you use to talk to your app, shouldn't really mean you have to rewrite the entire thing. So for example, if I wanted to swap out databases, if I wanted to swap out a MySQL database for a NoSQL database, that shouldn't require me to touch any of the business logic, right? My logic doesn't care where the data gets stored. So the Hex model essentially recognizes that need. You might be wondering, are the layers here the same as the MVC layers? And the answer is no. Because the MVC model tends to look at the inputs and outputs from kind of a top to bottom way. So you go from inputs, then the main logic, and then the outputs at the bottom. Whereas the Hex model, the inputs and outputs are just treated on the same level. I think that's why it's a hex, or you could make it a circle. It's essentially the same external surface. It doesn't care whether something is an input or an output. It's just an external interface. So how do you achieve that goal of not having to change much or affect unrelated parts of the app? Well, the key rule in the Hex model is that dependencies are only allowed to point inwards. So the outer layers can reach out to the domain as much as they like. They can use the definitions of entities and so on defined in the model and in the domain. But the domain absolutely cannot reference anything outside of it. So that implies a heavy use of interfaces and inversion of control. And indeed, we tend to have interfaces, or you pretty much have to have interfaces at every boundary between each layer. So the core domain will define the business logic in fairly abstract terms without caring about implementation details. And then the rest of the application will implement those interfaces to satisfy the domain's needs. And then those internal layers, in turn, will define their interfaces. For example, the application layer could define the interface for storage because it needs the storage to perform these functions. And then the outer layers will have to satisfy that interface and implement it with a particular storage type. So that means that as long as the interface required by the layer is satisfied by something, we can just swap them in and out really easily. Like we can swap the particular storage implementations as long as the interface is satisfied, everything's fine. So how would that work for our demo app? Well, we have kept the service packages, so we have adding, listing, and reviewing. They're in yellow here. So those 3 packages are kind of our domain packages. And you could, if you wanted to, put a subdirectory under the PKG directory called domain, and put all your domain packages in there. Some people like that, like the sort of very pure approach. I'm kind of undecided. I'm easy on this. I like keeping my structure fairly flat still, even in the DDD model. So I don't like my structures to become too much of nested trees or too much tree-like. So I tend to not put the domain top directory unless there are so many packages that it just makes your life easier. And now we also, you might notice that we've moved the struct definitions into each one of the domain packages. So the listing has its own definition of beers, and the adding has its own definition of beers, which is really nice because now we can get rid of that problem where sometimes we need to specify a property and sometimes we might not. So the adding package, the beer in there probably doesn't have a beer ID in the struct, but then the listing package probably does. And then we have packages in red, which are the input and output interfaces. So in our case, we just have HTTP and storage. And the HTTP package provides our handlers, and then the storage is the actual storage implementations. So you might have noticed that I also put 2 top-level directories, CMD and PKG. And you might have seen them in projects online, and if you're wondering what the hell is that, it seems to be a trend now in the Go community that has emerged over time. And it's kind of becoming a bit of a standard now. So the goal here is to separate the binaries from your actual Go code. So if you have at least 1 binary or more, you put them under the CMD package. So in our case, I've actually broken up the main function now into 2 in the main beer server and the adding of sample data, which solves another problem really nicely because now they're completely independent. I can run one without running the other. And then if your project also has a lot of non-Go files, like a lot of non-code files, like Docker files or documentation or anything else, it's just like a cleaner way to structure your repo is just to put all the Go packages under the PKG directory. So that's what it is. If your project doesn't have any other files, you can probably skip that. And then what if we wanted to add a new client? Like I said before, what if we wanted to add like a command line version of this service? Well, easy peasy. You just chuck in another subdirectory under the CMD directory and create a new binary, which could start the app in a different way. So it solves that problem nicely as well. And then finally, looking at the structure, we start to get a pretty good idea of what this app does just by looking at the names. I mean, we can see beers and reviews, and we can see verbs like adding and listing and reviewing. So this structure actually gives us quite a good idea of what the app does, including that it's a beer server and it has sample data adding. So I like this because it makes it easy to navigate. And like, if you apply DDD and if you apply the naming from DDD and you focus on the names that tell you what the package provides rather than what it contains, the code just naturally guides you through itself. Like reading through this code, you go on a walkthrough and the code just does it for you by itself. You don't have to put much effort into solving that by yourself. So I was a bit undecided on where to put the sample data files. I could move them from here to the sample data directory because they kind of belong there. Or maybe even better, I could put a top-level directory called resources or fixtures or sample data or whatever, and maybe define the sample data in a completely non-code related format, like a YAML file or a JSON file or whatever I wanted, and then basically get the main function to then input that file and parse it and turn it into Go arrays. So again, there's different options, and it's kind of just up to what you prefer, end of the day. And then again, a really good benefit of this structure that you kind of tend to notice only over time or in bigger projects is how easy it is to extend and add bits to it without really having to change much else. So suppose you wanted to add a different version of the API for your app. You want it to be, you want to maybe create an RPC version of that API, or maybe you want to have a SOAP API. Well, you just chuck in a directory under the HTTP package, And they all can still use the same services that are defined, so adding, listing, and reviewing. So nothing else needs to change. Brilliant. So this gets us to a pretty good state, I thought. Of course, this is probably an overkill for simple apps. Again, going back to what I said before, don't overcomplicate if you don't need to. I wouldn't say you need to necessarily start out with the CMD and PKG package directories. They are easy enough to add over time if you need them. So I'd say start out with the simple flat structure, and then you can always morph into this kind of structure over time, unless you know from the start that you're just building a very complex app. And then remember that you can apply the DDD thinking in a flat structure too. DDD doesn't really enforce a particular structure. So it just happens to be that if you think about your Go programs and group them by context or the domain, rather than by the functionality, the pure implementation detail, it tends to work in your favor. But you can use any of the, you can apply that at any level. So at this point, you might be thinking, is there a framework I can use that captures all of this? Yes and no. There are different frameworks out there. Obviously, the older ones that we know, like Go Buffalo and Go Kit, and lots of them. There is a link to the article here that lists, I think, the top 6 frameworks in 2018 for Golang. And they all use slightly different approaches. Sometimes they mix and match different approaches. Personally, I don't have a problem with using a framework if it fits my particular use case. They can be a great way to get started if you don't know where to start. They can save you a lot of boilerplate typing, and then it can give you some ideas or inspirations for how you can go about structuring your app. But I tend to not use frameworks and introduce them, unless I can justify it, just to avoid introducing that extra complexity that the framework inevitably brings with itself. So I think that starting out with a blank page, it lets you explore and try out different things and learn from first principles, like explore those different concepts, different design patterns. And then once you understand those different approaches, then it makes it easier for you to recognize them in any framework you come across later on. And then you can judge those frameworks better. You can then have a solid opinion on why this one is better than the other one. So that's why I haven't talked about frameworks much today. There is one project that I found interesting, which is the Go Build template. If you've never heard of it, maybe check it out. It's kind of like a sweet in-between, because it's a good shortcut, because it predefines a Docker file and a make file for your Go apps. And it has the PKG and the CMD directories, but nothing inside it. So it leaves the actual final implementation and the structure up to you, but it allows you to cut a corner and then just sort of bootstrap the project a lot easier. So this could be a nice in-between. A few words on testing before we wrap up. I think it makes the most sense to keep the test files next to the files that they actually test. I don't really see much of a reason to replicate the exact package structure, like the directory structure, under a separate test directory. I don't know, I don't really see any benefit to that. So I think keep the test files next to the files that they relate to. And if you're using mocks, again, it's fine to use a shared subpackage. Like mocks are reusable. There's no really a good reason to make them not shared. We all know there's 2 hard things in computer science, cache invalidation, naming and off-by-one errors. So a few words on naming, besides that it's hard. We all know that. Choose package names, like I said before, that tend to explain what they provide rather than the pure function that they are, whether something is a handler or whatever. Avoid generic names like util and common, because they just end up being the dumping ground for lots of unrelated stuff that just grows over time. So follow the usual Go conventions. I've put a link there to Andrew Gerard's very short slideshow on that. And avoid stutter. So something that I touched on before, try and not duplicate the package name in your struct name. So rather than doing strings string reader, try and do strings reader if you can. A very quick word on the main function, and I'll defer to Matt here. So main in general, in the sort of structure that groups by context, it should really be sweet and short. It should just initialize the thing and kick it off and not really do much else. And so I think, and I certainly observed that over time, that my mains, once I applied the DDD thinking, my main functions tend to look a lot like this. They literally just initialize stuff. They maybe do some flag parsing, like input flag parsing, although you could still probably do that in a different function. But beyond the very necessary initialization, they just defer everything else to the actual packages. So, time for a quick recap. The convention these days seems to be putting the binaries in a separate top-level directory, putting the rest of the Go code in its own directory. Like I said, if your project is large enough to justify it. Favor grouping by context instead of generic functionality. Also kind of stay flexible on this, adapt over time. If you're going to have multiple packages, probably a good idea to start using the domain, like to use the domain approach and start thinking about the domain rather than the functional layers and implementations. The implementations of actual external inputs and outputs tend to usually end up in their own packages. That just kind of seems to always be the case. Keep your mocks in a shared subpackage. Keep any non-Go files in the root directory, so everything from your make files to your Docker files, documentation, all of that. Keep your main short, make it initialize and tie everything together. Avoid global scope for better maintainability, and the init function. So the init function, the first problem I ran into with the init function in the demo app is in the flat structure, I actually put the adding of sample data in the init function. And the problem was that once I wrote tests for it, and every time I run a test for anything, it would run through the init file and try and add the sample data. You have no control, you can't turn init off. It will always run. So basically try and avoid it, I would say. So I'm sorry I don't really have a single formula for you to use. The truth is that there is no single right answer to code structure. Even my examples is just an example approach. You could have approached this problem differently. And they can probably be improved in many ways, so if you have any ideas, by all means, send me pull requests. I really like this quote by Bruce Lee, "Be like water." So don't be afraid to change your mind later on. Almost expect that you'll never get your structure right the first time round. Almost expect it to change. So, and remember that your domain and language and your application will expand and it will morph and it will change over time. So it's only natural that the structure will follow that and change as well. So be prepared to adapt. Don't overcomplicate for no reason. Consider the complexity of what you're dealing with before deciding on the structure. So if you know you're writing a simple app, maybe just don't even bother looking into DDD. If you know you're approaching a big problem, then maybe be prepared to use a more complicated structure. But go for the simplest solution for today. Don't try and code for the future. I really like this quote. Whoops, sorry. As simple as possible, but no simpler. It's, like I said before, it kind of captures the idiomatic go away perfectly. Above everything, be consistent in your approach. So it will help you, it will help your fellow programmers coming into the code base later on. Experiment, prototype. Prototyping will help you ask questions you didn't even know you should be asking. If you want inspiration, maybe look at the standard library. That's a pretty good example of good code structure. And remember that good practices and choices, they will come with experience. So, and we've definitely seen that in the community. We didn't start out having the CMD and PKG directories. It just emerged as a standard or a trend over time. And share your ideas. If it wasn't for people who shared those ideas, we wouldn't have all those best practices we have today. So share your ideas and maybe publish a blog post or something so that other people can benefit and maybe work on top of that. And speaking of those people, this talk wouldn't happen without those folks and many others as well. But mostly thanks to Peter Bergen and Ben Johnson and Marcus Olsen. All of them published a lot of information online and their thoughts on code structure. So I just wanted to say thank you for sharing the thoughts with us. And I've also put a few more links in here. So there is an article about package-focused design on the Gopher Academy blog. Marcus Olsen actually gave a talk about his DDD port of the very famous Java example of a DDD layout at Golang UK, I think in 2016 as well. So there's a link to that. Brian Kettleson actually gave a talk earlier this year at GopherCon Russia, it sounds very complementary to my talk, so I'd encourage you to go and watch that as well. It kind of goes into a bit more detail on naming and a lot of things that I maybe haven't gone into a lot of detail today. And if you want to find out more about hexagonal architecture, there is a really good blog post by Chris Fidao on that. If you have any feedback or if you want to ask me any questions, feel free to tweet me. My Twitter is at the top. You can do it at any time. And finally, my demo code can be found on GitHub. I will tweet out the link to the slides and the repository, so you can go through it in your own time. There's clear directories marked for every single one of those structures, so have a look at it in your own time and see if it makes sense. So with that, I hope you enjoyed the rest of the conference, and thanks so much for listening.